All right, hello, Algebra 2. This is the last lesson. Yay, we made it. Lesson 9.3, radical equations. We want to solve, so getting solutions for x, and be able to check my solutions. And we're going to remember that we can check on the calculator pretty easily. So get your calculators out, know how to use your calculators, or desmos.com. We can do it graphically and we can do it just numerically with numbers, but we do want to be able to check our answers. Okay, so example 1, remember, you need to make sure that you are copying down the directions so that you know the difference between solve and factor. Okay, so first of all, this is a radical equation. You can see it because it has a radical in it, and we need to isolate the radical. And that is the first step to solving these equations. So what I want to do is get rid of this -3. So we're going to go ahead and add 3 to both sides so that we get this radical all by itself. 6 plus 3 is 9. So what we've been learning is that radicals can actually be written as exponents. And for this first one, I'm going to do it this way. I'm going to rewrite this radical in exponential form. So it becomes 3x plus 63 to the 1/2 power. Well, that's kind of interesting because what I can do to cancel out that 1/2 is I can raise it to a power of 2. And so I'm allowed to square both sides of an equation. Square both sides. All right. By squaring both sides, we now have this power raised to a power form. And if we were to multiply those exponents together, which is what we were doing in the previous lesson, 1 times 2 is 2, and 2 times 1 is 2. So we would get 2 over 2, which reduces to 1, which means that exponent just sort of cancels each other out, leaving the 3x plus 63 all by itself. No more radical, all right? And then 9 squared, 9 times 9 is 81. So square both sides. When you square both sides, that square and the square root end up canceling each other out. You probably understand that, but this is mathematically what's happening. So can you go from here to here? Yes, you can. Now we just have to isolate x. So that's the third step. Isolate x. All right. So we can start by subtracting 63. 81, take away 63. Oh, Lord. This math I just cannot do this morning. All right, 18. Okay. And then we can go ahead and divide by 3. So we get x equals 6. Okay, so how do we check this? There are some great ways to check, and one of them is to check the graph. Always a good idea. So to check the graph, what we're going to do is we're going to put the left-hand side of the original equation in y1. So we're going to do the square root of 3x plus 63 and then minus 3. And then the right-hand side of the equation in y2. This is a great way to check any equation. Left hand in y1, right hand side in y2. I'm going to go to my graphing menu, delete my equation. Okay, square root, there it is. Square root quantity 3x plus 63 in parentheses, and then subtract 3 on the outside. And in y2, I'm putting in 6. And then I can go ahead and draw that. So there's, look at that. See where they intersect? So little sketch of this, and you can see we get this sort of weird curve and then this horizontal line, and they intersect right here. I want to figure out where that intersection is, so I think the answer is 6. So we can use trace and see what we get. There's trace in yellow there, so shift trace, and I'm just going to type in 6, and you can see it's right there where the two lines intersect. That's sort of a way to do it. You can also use the solve menu on this calculator. So G solve, so shift G solve, and we want the intersect, ISCT, and if you just press intersect, you can see we get x equals 6, and that is the intersection, which is very, very cool. A little bit harder on the TI, so I'll do that one next. We want to isolate the radical, so I'm going to start by subtracting 10. So we get the square root of 8x minus 55 is equal to 11 minus 10 is 1. Then we can square both sides. That's going to cancel out the square root, so we're going to square both sides. The square root and the square cancel out, leaving the inside. 1 squared is just 1. And then we can isolate x. So to do that, we're going to add 55. So we get 8x equals 56, and then I can divide by 8. So we get x equals 7. This one's a little harder to do graphically. I'll talk about why. So I'm going to go to my equation. I'm going to type in the square root of 8x minus 55. And then on the outside of the radical, plus 10. If you're using the Casio, you've got to put that in the stuff inside the radical in parentheses. So we're going to check by plugging this in the whole left side in y1 and the right-hand side in y2. And I'm just doing a zoom standard. And when you look at this graph, you don't see anything. What's the matter? This value on the y-axis is 11. This axis is only going up to 10. So I need to change my viewing window. So I'm going to change my window and make the y maximum higher, like maybe 20, because this is higher than 10. All right, and so now we can go back and look at the graph. All right, that's kind of interesting. What we see by moving this all the way up to 20 on the y-axis is we see our nice little horizontal line. That's the 11. And then this is the square root little function. It just looks like this. And right here is where they intersect. So we want to look at that intersection. We want to calculate. So that's the blue menu right there. So we're going to do second calculate. And then number 5 is intersection. And on the TI, this is much more challenging. I'm going to arrow up, and it's going to change. You see there's a move to the y2 equation, and there's Tinkerbell. We just need to use the arrow keys and move Tinkerbell to where we think the intersection is. And then it says first curve, you press enter. Second curve, Tinkerbell is where we think she should be, you press enter. And the guess, press enter again. And you can see that the intersection is 7, 11. The x value where they're intersecting is 7. And that y coordinate is the 11 that we were looking for. Okay, they have that point in common. All right, very cool. Learning how to use your calculator to solve equations is totally awesome. Example 2, solve for x. Same idea. Isolate the radical. Well, it's already isolated. Square both sides. So step 1, isolate the radical. Step 2, square both sides. This is where it gets a little more complicated. The square root and the square cancel each other out, leaving the inside. But over here, this is x plus 6 times x plus 6. And what do we have to do to multiply those? Yeah, we have to multiply these bubbles together. So we are going to do that. First times first. X times x is x squared. X times 6 is 6x. We're going to distribute the 6. That's the inside there. 6 times x is another 6x. And 6 times 6 is 36. So we have 8x plus 48 equals all of that. This is quadratic, and so we need to set it equal to 0 to solve. Now, what I want to do, this is a positive x squared. I'm going to move all this stuff towards this positive x squared. But first, I'm going to go ahead and clean this up a little. 8x plus 48 equals x squared plus 12x plus 36. And I'm going to move everything to the right here. I'm going to subtract 8x. And I'm going to subtract 48. So they go away. So we are set equal to 0. We have positive x squared. 12 minus 8 is 4 x's. And more math I just can't do right now. 36 minus 48 is negative 12. I should have been able to figure that out. And we need to factor double bubble to solve. X times x is x squared. What times what is negative 12? Negative 3 times 4, negative 4 times 3, negative 12 times 1, negative 6 times 2, or negative 2 times 6. Winner, winner, winner. Ding, 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 ding. Positive 6 and negative 2. Remember that you can always check the rainbow to make sure that you did it correctly. Negative 2x plus 6x is 4x, and that's where that middle term comes from. And then the last step is to solve for x. So we set each bubble equal to 0. And then move it over so we get x equals negative 6 and x equals positive 2 as possible solutions. So how do we know if we did it right? The very last step, you must check your solutions. And so to check, again, I'm going to go to the graph. And I'm going to put the left-hand side in y1 and the right-hand side in y2 of the original equation. Always the original. I'm never going to use anything but the original. So square root of 8x plus 48, whoops, in y1, and then x plus 6 in y2. And I'm just going to do Zoom standard to get started. And you can see we have a little sketch. The square root has this sort of swoopy shape, which we'll actually talk about more. And then you have x plus 6 is just that straight line. And you can see that it looks like they're intersecting about here and here. And what we can do is we can actually, another thing you could do, we could just use trace because we solved for x. Negative 6, we have an output of 0, and that's very good. And I can change the equation. Oh, it always reverts. Huh, funny. Oh, okay. Trace 6 and, 6, not 6, trace negative 6. And we get Tinkerbell right where we think she is at negative 6. And I can also trace at 2. Trace 2, and again, I see Tinkerbell is just about at that intersection right there at 2. That's not a great check, but I can actually look at the table. That's kind of a cool thing too. Look at the table. It's blue. Second table. And you can see that if you arrow up to -6, look at the outputs are the same. They have the same y value. That means they're sharing a value. And then if you go to 2 for the x, again, they have the same ordered pair. So they have a point in common. So that totally works. I will use the Casio for the next one. All right, again, we're going to square both sides. Square and square root cancel out, leaving 16 minus 5x. And this is x minus 2 times itself. Repeat 2 times. So I'm going to go ahead and FOIL that. X times x is x squared. X times -2 is -2x. -2 times x is -2x. And -2 times -2 is +4. Then I'm going to move everything to that x squared side. So I'm going to subtract 16. And I'm going to add the 5x. So I get 0 equals x squared. -2x and -2x would be -4x. Plus 5 would be +1x. +4 and -16 is a -12. Then I can factor. X times x is x squared. What times what is -12? Let's see, -6 times 2, -3 times 4. Oh, yes, yes, yes. Winner, winner, right there. -3 and a +4. And again, you can always check the rainbow to make sure you did it right. Will give us a +1. And then we set each bubble equal to 0 to solve. Isolate x means we've got to move the 3 to the other side. And then again, move the 4. We change the sign. So how do we know if we did it right? We're going to look at our calculators. And in Y1, we're going to put the left-hand side, and Y2, we're going to put the right-hand side. So I'm going to show you how to do that here. Casio, exit. Okay. Delete. Yes. Delete. Yes. Okay. So square root, parentheses, 16 minus 5x. Close the parentheses. And then we want x minus 2 in our second function. And I can just hit draw. And so again, we see, this one's kind of interesting. I see my line. That's the x minus 2 line. And then this little swoop sort of shape. But look, it looks like they're only intersecting at one place. That's interesting. So I want to go to the table and just verify where that is. So you do have that on this calculator. If you go back to menu, and then you see table right here. So on the TI, we just do second table, but on the Casio, we have to go to the table. It has the same functions already put in, and you see table at F6 here. And we want to check our X values and see which one gives us the right output. So let's go to -4. Oh, your table might be reset. On your table, you can actually just type in -4. There it is. Look at X, and then we have Y1 and Y2. So your table is a little different probably than mine because I changed my table settings. But you can just type in -4, which is super cool. And you can see that you have an output at Y1 of 6 and -6. Those don't match. That is not a solution. When we type in 3, you can see the outputs are matching. And so that is that ordered pair at 3, 1. That's where they share a common point. So x equals 3 is the proper solution. This is what we call a false positive is really what it is, false solution. And that just happens because of the nature of solving quadratics. Squaring both sides can potentially create extra solutions that aren't really there. Just mathematically, we have to do it too. That's how you have to solve it. So always double check anytime you're squaring both sides. Let's try one more. Oh, perfect. All right. the radical is isolated, so we're going to go ahead and square both sides. The square and the square root cancel out, leaving 21 minus 10x. And here we have x minus 3 times itself, which means I need to FOIL. First times first is x squared. The outside is negative 3x. The inside is negative 3x. And the last times last is positive 9. I'm going to go ahead and I guess clean that up for you. So we have x squared, negative 3x, and negative 3x is negative 6x. And now we can move everything, push it over to one side. So I'm going to go ahead and subtract 21. And I'm going to go ahead and add the 10x to its like term. So I have 0 on the left, and I have x squared. Negative 6x plus 10x is positive 4x, and 9 minus 21 is negative 12. Yeah? Man, everything was 12. Okay. So now we factor. X times x is x squared. What times what is negative 12? Negative 3 times 4, negative 12 times 1, or 6 times negative 2. And there's our winner right there. Positive 6 and negative 2. Remember, you can check the rainbow. That's where we get that 4x from. And then we're going to set each bubble equal to 0 and isolate x. Isolate x. So we get 2 possible solutions that could be wrong. So let's check our answers. So once again, to check, we're going to put the left-hand side in y1 and the right-hand side in y2. So the square root of 21 minus 10x, and then x minus 3. And again, you can use Desmos.com if you don't have a graphing calculator. Same process, except easier. Look at these. So we have our line, that's the x minus 3. And then here's our square root function, that funny swoop. What do they have in common? No intersection. They don't intersect, which means there are no solutions, no points in common. Well, let's double check the table. Let's look at the table. So I'm going to go second table. And we thought we had some solutions. We have x, and we have y1, and we have y2. So let's go back to our negative 6. Negative 6, we have a 9 and a negative 9. Those are not a common ordered pair. You can't see that. There you go. Our other solution was positive 2. And at positive 2, we have 1 and negative 1. That is also not a common ordered pair. So it turns out that both of these are false solutions. There are no solutions here. No real solution. Okay. So using your calculators is very good, very awesome. Please learn to use your calculators, or at least Desmos.com, all right? And setting, you can solve any equation this way if they have real solutions. Put the left-hand side in y1 and the right-hand side in y2. Please practice. All right, ladies and gentlemen, that was 9.3. Let me know if you have any questions. I'm here to help.